tam może będę coś próbował robić.
Proszę bardzo. Dobrze dogiąć.
A, bo jeszcze ucho też zrobiłem.
Tak, nie wiem.
Łapie teraz?
Włączyłem i wyłączyłem. Ale idę zobaczyć czy łapie na telefonie. Nie podłączać, tylko to coś.
Zakładam, że mogę Cię tutaj... mogę Mateusz odpiąć? Czy Mateusz możesz odpiąć? Mateusz, mogę Cię odpiąć, nie? Tutaj, bo tutaj nie ma wolnego żadnego. Bo masz pełne.
Tak.
Tak, mogę?
Tylko potem podepnij, bo to, żeby się streaming nie wyłączył, tak?
Jasne. Postaram się pamiętać. Tak, ja będę o tym pamiętał, spoko. Masz już u siebie mój ten ekran w razie potrzeby?
Dodamy Ciebie do...
Dobra, 45 minut, czyli jeżeli zaczynam... Czyli do wpół do. Czekaj.
Mateusz.
40 po 25
Do 25, tak.
Tak, i wiesz co, jakbyś tam to 20 po byłoby...
Postaram się, no. A jakby to po prostu zetnę temat, bo to też jest tak, że wiesz, można...
Nie, można powiedzieć, blokować 25 minut, ale 45 minut, że spoko, trzymaj coś tego, jakby Ci się udało 5 minut ściąć, to chętnie, bo ja się jeszcze potem chcę zmieścić.
Pokazuj mi po prostu. Nie,
Dobra.
będzie takie, wiesz, to...
Pokazać Ci, jak się będziesz zbliżał?
No.
Jakieś 10 minut, 5 minut?
5.
Dobra.
Muszę ciągle stawić z tym mikrofonem, coś jest zjebane. I...
Raz, dwa, trzy. Raz. Tam jest delay, pamiętaj. Nic.
Jeszcze... Halo, halo. Słyszysz to? Tam. Halo, 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 halo. Halo, halo. Nie słychać. Halo, halo.
Dziękuję bardzo.
trzeba 1 do 3 spróbować. 3, wiesz, 1/4, 3/4. Nie, 1/4 i 3/4. 1 do 3.
No, tak, to jest może większe miejsce, bo my od nich, to nie obywatele od tego miejsca, mamy zadanie.
My szukamy
Teraz pierwszy raz musimy to powiedzieć,
A jak robicie, w sensie piwo, macie jakąś fundację, czy to po prostu Mateusz na firmę?
Mateusz na swoją firmę i się potem do Handsontable rozlicza.
My z tym naszym wsagiem w Warszawie to też szukamy takiego miejsca. W Krakowie bym szedł do C, tutaj bym szedł tu, albo do Oliwii, nie? Tam Oliwii, no, nie wiem czy to jest Oliwa czy Oliwia, ale Oliwia. Oliwa to jest dzielnica, no i właśnie mi się to myli, nie? Natomiast w Warszawie albo nie znaleźliśmy jeszcze czegoś takiego. Ja na przykład gadałem w ogóle, pierwsze miejsce to było oczywiście Paramount. I coś tam nie pykło, nie? Oni tam bardzo często, nie?
Wszystko ok. Switching back to English, ladies and gentlemen, please grab a beer, grab something to drink, take a seat, and we will have the very next and very special as well speaker Tomasz Ducin with topic The Forgotten Art of Thinking, How to Learn with LLMs without increasing cognitive depth. Okay. Tomek, whenever you're ready, huge applause to warm Tomek.
1, 2, 3. Thank you very much, Michał, for a nice introduction. So, yeah, we're going to speak about thinking, generally, not thanking, but thinking. And my small, let's say, mission or motivation is to affect your priorities so that you invest your effort and time in slightly different things. And that is thinking in a very special way. And speaking very shortly, pretty much everybody is speaking about, generating code with LLMs. And well, more and more people are starting to discover that LLMs are actually great for learning generally. But you need to do that with some kind of special attitude so that you don't make things worse than they used to be before. So, yeah, we are going to speak about some things like, you give me the prompt and then you're an expert. You never make mistakes, right? So we're going to battle some kind of stupid ideas that people throw there or here or there. For instance, writing in your prompt that you are an expert in, React or Angular or Java Spring, etc. Like, it just consumes a bunch of tokens, so it's not much, but it actually doesn't bring too much benefit, and we're going to discuss why. And also, you never make mistakes, right? Because, yeah. Or we are actually not going to speak about army of agents that are going to, replace all employees in your one-person company, and that was supposed to, bring you millions of dollars, etc. And that agents follows prompt instructions, because actually agents don't even read what is the prompt or what is the answer from the model. Agent has a lot of work to do, but it actually doesn't do anything with the prompt. It doesn't read it, it doesn't modify it, etc. Right? So we're going to fight some misconceptions and misunderstandings. And quite often, in order to use a thing, you can treat it as a black box, but it is an limitation, a quite important limitation, that if you don't understand or you don't have a slightest idea about the internals of a given thing, you are not aware about the limitations. You don't know how to use it effectively, what to do, what not to do, etc., etc. So, in theory, there is no difference between theory and practice, and in practice, it seems that there is, but still, some pieces of theory are very useful to basically get to know what ideas make sense, what ideas do not make sense, and I hope that after this talk you will build some kind of intuition of what could be a good addition to a prompt or to a sub-agent, to a Claude skill, basically whatever you're using, and generally, yeah, how not to increase, let's say, false assumption that you have done a piece of work or that you do understand. Generally, we need to walk deeper. We need to ask more whys, like, start with why, the 5 why approach, etc., etc. So we're going to dive down into these topics. So my name is Tomasz. I've been working in the industry for something like 2 decades, initially backend, then frontend for a decade now. I'm working back in backend, and actually I like to call myself a software generalist, because also that's another topic, but I believe that if you don't have a niche in which you are a super expert, nowadays it makes way more sense to get closer to business priorities, to what are the, let's say, limitations that business wants you to remove, the opportunities you want to unlock, etc. And basically, you don't need to be an expert in everything, but the more, let's say, self-sufficient you are, the more attractive, the more useful you're going to be basically for your company. Yeah, and my pretty much almost last year, nearly, I've spent on creating the Developer Jutra course around AI. So there is a quote that I like a lot by American General Dwight Eisenhower, saying that plans are worthless, but planning is everything. And I would like to slightly modify this quote by rephrasing it to remembering things, just that I remember a fact, a thing. Remembering is worthless, but reasoning is everything. So basically, when you learn something, what I found, and I would like to kind of try to convince you to this approach, is not to remember facts, but try to do as much problem solving when you learn something, so that even if you don't remember this thing after 1 week or 2, but in your job, when you will be facing a special, let's say, obstacle or a problem to solve, etc., you will remind yourself, oh, I have been solving such a problem, such an error, mistake, whatever, some time ago, so that you will know where to look for. So basically, reason about things, understand them, but not necessarily remember them, right? So also, if basically something rings a bell to you, and you can identify, oh, this is a problem that some other topic was, connected to, that I was working on the problem. You could dive deeper into it, what some people say, just-in-time learning, so that you don't have to be an expert in everything immediately, but you need to at least identify the areas so that you can connect. What is the problem that you're seeing, that you will be even, let's say, capable of identifying the problems, and what is the area on which the problem needs to be solved? Because what we programmers suck quite often is that we want to solve everything with technology, or we want to solve everything with not the right technology that it's meant for. For instance, some issues or limitations need to be solved on organizational level or on architectural level, and quite often not on the code level, right? So first we need to understand the problem, right? And reasoning is everything. Also, some, let's say, thought leaders claim that one of the most important skills in upcoming years is going to be critical thinking. I agree, wholeheartedly with that, though it's very difficult to say what actually critical thinking means. And this is what this talk is going to be. Yeah, so AI is absolutely great, but it has some limitations. But we're not only going to be speaking about coding, but first of all, learning. Yeah. There is going to be a little bit of opinions that might be different than your opinions, but I hope that's going to be okay anyway. So again, another quote that is very kind of close to my heart is by the psychologist Carl Jung, who said that, or wrote that thinking is difficult. That's why most people judge. There is, let's say, some limitation or some problem with our brains, and that is that, when we try to think critically about something, we burn calories, we burn energy in our brains, and this is, like, our brains is a machine that burns a lot of energy. Really a lot of energy. And the evolution has made us human beings, work in a way that if something can be kind of solved or a decision can be made automatically, then we don't think too much, but we just act kind of using an instinct, right? Like kind of automatically, right? So that I can see somebody, or maybe, yeah, I see a lion, right? Or in the savannah, so I know I have to run away. But if I, let's say, see a issue that is happening in my system, and I think, I have seen such an issue some time ago, then there is a risk that I would immediately jump to a train to solve an issue that doesn't have to be the same issue, right? It could have slightly different characteristics, but to solve it exactly the same way that I've done 2 years ago, 3 years ago, but the company is different, the team is different, the system is different, etc. So there are many factors that could basically make my solution from a few years ago not fit current situation, right? So thinking fast is basically when we do something intuitionally, we act very fast, and our brain consumes little energy. And basically evolution has kind of promoted this, because if we were super analyzing everything around us, then we would basically die from hunger or whatever, right? Or just, wild animals would eat us. So fast thinking is nice, but not when we need to think about, let's say, systems, when we design stuff, when we make decisions that could have big consequences, right? So one of the key skills here is how to identify whether a decision is important. How much energy should we put into it? And now, thinking is difficult, that's why most people judge. Now, from my observation, people don't even think about that factor, right? So if I have seen something, then I would basically reapply the pattern, the solution everywhere. And also, if I was working at a company or 2 companies and I have 5 years of experience, etc., then I have an opinion about every topic and I know absolutely everything, right? So people tend to judge things, and I would like you to kind of get interested more in asking questions, more to kind of, embrace questions and not the answers. Because if you're working in a given system and you ask yourself, for instance, should this be a front-end monolith or should it be micro-frontends, whatever, then the answer could be, let's try to go with, let's say, a front-end monolith. Cool, this is a answer. But if you walk into a different system and you would say, okay, let's reapply what I've been doing. So you've got the answer that is ready, but the thing is the context has changed, for instance, right? And now, what I see pretty much everywhere around in our industry is that people have answers that are ready, but they don't reevaluate their answers basing on what has changed in the context. So this is, I would say, the number one reason for making the most expensive mistakes in software design, in systems, in architecture, etc. So basically something worked for me once, so it will always work for me. And basically ignoring the changes and ignoring the fact that there is entropy in the world, in the universe, and that basically we change, our systems change, business changes, the customer expectation changes, etc., etc. So basically have less answers, have more questions. This is what I would like to kind of convince you to change in our thinking. Also, when we're speaking about LLMs, you might have noticed that quite a lot of people are referring themselves to research about artificial intelligence, especially on Archive or other, let's say, sites which accumulate various research methods. Now, what bothers me about that is every research is very useful and great, but if you have one research, it's not enough to make a very general statement, for instance, that Polish language is the best for prompting or whatever. What we need actually is that research always have some kind of assumptions. It always have some kind of, test group, specific people in specific region, in specific culture, in some specific circumstances that might be included in the research, but they might not be included in the research. So what's very important is that in the research method, that's basically something like no rocket science. It's generally obvious to anybody who works in science, and that research results must be repeatable. So if you can see a, let's say, research on archive saying that, let's say, developers are getting slower because of using AI. Okay? Then you walk into it, and it turns out that, okay, but these devs were working on open source, and they were working individually. They had their, let's say, conventions established, and they were very, very, very strong. So how does that apply to the work that we do? Do we make money on open source? Do we work individually? Like, okay, maybe you do, but most of us, don't we work in business systems, business applications, right? So this does make a change, like what is the context in which we work? And now, if we make a, let's say, a research about open source developers who work individually on well-established code bases, now okay, but still we need to repeat that research. And if we see that, let's say, devs in US and devs in Europe and devs in Asia, Africa, whatever, we get the same or similar results every time, now, yeah, this becomes kind of credible, sure. But if we have just one research that only, like, you know, proves one thing, right, then it's kind of, okay, we have some data, and I'm not questioning it. We have some data, but we don't know how general this data is, how kind of narrow it is. Can we extrapolate that on the population, right? So what I'm saying is not that it's good, not that it's bad, because this is an answer. This is a damn judgment. This is an opinion. What I would like you to kind of, you know, shift your thinking is to question things constructively. Okay, so this research shows that developers are getting slower. Okay, so what were your assumptions? What were your circumstances? How is that repeatable? Okay, how much data do we have? Is that repeatable? So what was the, let's say, criticism, of course, constructive criticism behind that thing? Like, okay, let's gather the data, let's discuss it. What good questions do you have? How could you, how could you question the thing, right? So whenever you're learning something, for instance, you walk into a conference and you would have a new topic, let's say, coding with AI, and that AI can generate code for everything, blah, blah, blah. I have a simple heuristic. Always ask a question like, what are the downsides of the thing? Because in, let's say, for instance, on conferences or on blog tutorials, etc., people tend to focus on what is the best thing about a given topic, a given area. So what is generally, what are the downsides? Where are the situations when things can go wrong? What are the, let's say, bad applications or kind of, you know, downsides, etc., etc. So how can you question that? Or let's say, what were the lessons learned from using the thing? Like, what were the bad consequences? How can you fail with that, right? And now, when you learn something with LLMs, generally LLMs are going to use internet. Surely. So now, the first thing here is what kind of input, data input, what kind of feed is the LLM going to get from the internet? If somebody is speaking about a technology, about an architecture, about a framework, tool, pattern, whatever that is, if you ask about a thing, what kind of reply, what kind of information are you going to get? If you're going to ask about a given, let's say, framework, and if it kind of concentrates on the exact code, then code is something very, let's say, specific, very kind of clear, and it might not have too much assumptions. But if you're going to ask, for instance, you would ask about, is a given architecture, let's say, useful in a situation, right? And try to think, what kind of Google results would you get for a given phrase? Most probably positive answers, right? But there is also one thing. If you ask, for instance, please give me, of course to an LLM, please give me examples where something is wrong. Let's say you have 20 teams and you would ask about, do micro frontends fit a product where 20 different autonomous teams work on the product? The short answer is, if done correctly, this fits this situation because each team needs to be separate. So we basically break the system into separate autonomous pieces, etc. So in case of microservices, micro frontend, this potentially would be a good fit. But if you're asking the LLM to find bad things about something, then this is the task. So it will give you bad things. They can be kind of very different on the quality. If the task is to find something bad, it will give you something bad. Right? But it doesn't have to make much sense, generally speaking. Right? So going back to thinking fast and slow, dear everybody, so again, if you see an opinion, if you see a statement, whatever that is, try to basically critically think about how could we, let's say, question the topic, ask questions, etc., and also try to, let's say, decide whom do you trust. I mean, there was a situation, for instance, with the author of OpenClaw, Peter Steinberger, I guess, that was his name. And when he was hired by OpenAI and so on and so forth, there were lots of influencers, LinkedIn shamans who've been saying, "Oh, he is such great. He has never done any kind of GitHub contribution. He has done 100 GitHub contributions, but he has never done such a business. He is such a genius." It turned out that it just takes a simple Google search to find out that he had a business and he has exited with millions of dollars, so he could basically not get to the job at all entirely. And basically what it shows is that people who speak a lot try to test their trustworthiness, because lots of people basically say a lot of garbage. And now I'm not going to suggest who that is, just find yourself, but always ask how trustworthy is that, how to question things, etc., etc. If you haven't read that book, I would suggest you a lot. So Daniel Kahneman, Thinking Fast and Slow. Basically, it's a book that is quite simple, quite nice to read. It's not very difficult. It shows lots of ways where you can kind of opt out from acting like an animal automatically, but trying to activate your brain, activate slow thinking where it really matters. For instance, you need to make a project decision. You need to decide how do you approach a meeting, and you're under stress. Quite a typical situation, isn't it? Right? And if you're under stress, you're stressed, it's way more probable for our, for our brain and how it evolved during, thousands of years, to basically act like an animal and basically, to defend yourself, or for instance, my code is better than yours and I'm going to fight for it, etc. So lots and lots of simple situations where you can kind of shift from it. Of course, it's model is going to do that better for you. Now, I'm not going to say never do that, but I would say we need to identify what are the consequences for the decision, for not the right decision to be made. Also, if, let's say, I ask the model to make a decision about the system design and software architecture, who is responsible for that? Now, we speak about that as a community more and more, so now it's quite, let's say, obvious that it's the human being that takes the responsibility, right? But who actually, but yeah, the human, let's say a senior developer or mid developer, whatever, they would say that, hey, but it's the model who decided. But who has submitted the prompt? Who has confirmed the prompt's response to be actually applied in practice? So it's you. And now, I'm not saying that you should, like make decisions about each React component, each, I don't know, REST, Spring controller, MVC, REST, whatever. No, but if there is something that could be, let's say, rough heuristic, expensive to change in the future, you take the responsibility. And if something is cheap to change, then if there is a problem, then basically you pay a cheap price, a small price to fix it. But if something is, let's say, a big level architectural decision, for instance, who should be responsible? How do you shape teams? How do you make your team or your developers responsible for maintaining a component library? If you have 3 teams, would you shape a separate team? Would you kind of mix the responsibility of, I don't know, some partially all the teams would be responsible for that, etc. Now, would you delegate such a decision to the model? Every company is different. Every product is different. Culture in every company is different, right? And now, how is the model going to suggest you the answer? Basing on what the model has, what it has been trained on, and what it found in the internet, right? And now, you take the responsibility, and this is something that could basically, well, it might not kill the product or kill the business, definitely, but it could significantly slow down. So I would say don't delegate thinking. So the model can be super useful. For instance, what are the, let's say, I would ask the model, please give me case studies on the design of component libraries in bigger organizations. Show me what were the, let's say, success stories, what were the failure stories, etc. Bring me the arguments that there were. And this is going to be the input that would kind of bring context to me. And I like to think that LLM is super great for doing a wide research, for kind of exploration on the topic, like wide, not definitely deep, but wide. And I get all that data to my brain, I compile it here, and I make the decision here. So I can use LLMs for doing a lot, especially the research, but I compile it in my brain. Because again, LLMs are, to some extent, giant statistical and probabilistic models, right? Difficult to say whether our brains is also statistical or probabilistic because we don't know that much about our brains. We know a lot about transformers and LLMs architecture. We know a lot less about ourselves. But I would say don't delegate thinking. By the way, if you would say that, oh, Claude Opus for 6, for 7, or whatever, 1500-1900. If the next Claude Opus is the best model always, and you want to delegate everything, why would the business hire you? Why would the business pay you? Like, generally, try to think, what is basically the value that you bring to the company if you want to basically push everything? And I'm not saying to keep job security, not at all. By the way, I've been doing trainings for years, and right now I'm saying, don't buy trainings because you can find lots of stuff here, or at least about technology. So now I shift to different things because I say myself, it doesn't make sense to learn frameworks with a trainer. You can learn design or architecture, etc., because this is not that well covered, but some things just don't make sense, right? So thinking critically, I would say, is the #1 skill that would be used. Yeah. So the question is, if model says something, how to verify a given answer, and how can we work with that? There are many models like, let's say, the Dreyfus brothers, or the kind of there are many models to basically divide how advanced somebody is. And there is also the known-unknown matrix that I'm going to refer to. So the unknown unknowns is the first step, then is the known unknowns, known knowns, and unknown knowns. So the first step is that I don't even know how incompetent I am. So basically, this is, people don't like thinking, people love to judge. The less experienced they are, the less they know, the less imagination about the topic, the more they will basically produce judgments, opinions, etc. Like, I don't have the data, but I have lots of opinions, right? So I don't even know what I don't know. Now, I am at least aware of my incompetence, of lack of incompetence. So I would say, generally in software, I would suggest to try to do this ASAP, so that at least, you don't know how to solve problems here, but you do identify problems and you can kind of categorize them, where to look for the answer, or at least not only the buzzwords, the catchy features like, I don't know, domain-driven design that we're going to walk into, but also, for instance, that domain-driven design is not about doing whatever you think the domain is, but it's actually about talking a lot to business and to figuring out how to shape your system according to how the business works and operates. This is what DDD is about. It's not about aggregates, it's not about subdomains, etc., and it's definitely not about Angular monorepos. If there is anybody who has heard it, and unfortunately, Angular community is spoiled, but it's a different topic. So basically, try to at least attach what a given topic is about, right? Known knowns is something is an area in which you know what is the answer, or generally you know how to solve a thing, right? But you still need to, it's not something that you have done 100 times, so you need to still proactively think about the topic. And finally, if you're an expert and you have done a given thing many times, you can do it automatically because you just identify the abstract things because you've done it 100 times. So there are topics in which I am in unknown unknowns, and if I only identify, it does matter in IT, in software industry. And for instance, 2 years ago, strategy, business strategy, was an area in which I was in unknown unknowns. But this is my target, to basically think about business strategy, and this is something where I would say I'm somewhere in the middle, right? So everybody has some areas in which you can improve, but it doesn't mean that you have to learn everything now, because there is basically too much of it, and you might not need it right here, right now. So basically, if you're here and you find tomorrow in your work that you need to know how to solve a specific issue, then you know where to look for and basically do this just-in-time learning, right? Now, going technically, when you learn something, the model could hallucinate. The model could tell you something that is wrong. And now, how does it work? So first of all, there is a, let's say, big pile of data here inside the model that is called the transformers layers. And I would like to show you something from Hugging Face. And for instance, there is a model that you know at least from a name, DeepSeek. Now, it's not yet something that you would execute, run on your machine, but you would rather get something that is, standardized in a way that you can run it on Llama, Ollama, etc., etc. It's just a format. But still, we would see that there is a lot of various, let's say, versions over here. So we have what is called quantization. So models can be compressed always from a very good quality to worse and worse and worse and worse quality. Think of it as konie mechaniczne, mechanical horses? Horsepower. Thank you. Think of it as cars that could have a stronger engine or a weaker engine with more or less horsepower. And let's say that this is the original quality that has 16 bits, so 2 bytes, for each parameter. Now, how many parameters do we have? Nearly 700 billions, 700 miliardów in Polish, because it's billions, and in Polish miliardy. Funny translation here. Though, imagine, in original value, you've got 16 bits for each of these 700 billions. And now, this is, let's say, the full quality for a given thing, and now these are all numbers. The model never sees a text. So the text is chunked into very small pieces, and it will basically glue the semantics of what you want to take a look, of what you want to analyze. And now, if you have 16 bits, then you can have 2 to the power of 16, that is kind of 65,000 possible values in 16 bits. Now, if we quantify it to 8 bits, how much do we get? 2 to, no, not half. From 65,000 to 256. So it's 256 times less possible values. It's exponential, right? Not linear, it's exponential. Now, if we make it to 2 bits, how many values do we have? Possible values? 4. And now imagine, if you have a parameter that used to have 65 possible values, and now you have 4, how degraded the value is. And now, if we have open models, everything is fully transparent. Even Chinese models are transparent, but the weight in the parameters and the data training is not transparent, but at least quantization is transparent. And now, if you pay for Claude Code or for Codex or for whatever, what do you know about quantization or the parameters? What do you actually pay for? Do you think the vendor wants you to know about quantization? Do you think the vendor wants you to know about the training data? Now, if you are ever surprised that Copilot, maybe not Copilot, that Claude Code used to be very useful in coding stuff, and at some point it basically returns you garbage, oh, what has happened? Well, there was a change over here, right? By the way, there is nothing like Claude Sonnet 4.6 or 4.7. There are lots and lots of different versions of 4.6, right? Imagine, if you have lots of horsepower, let's say 250 horsepower, this is going to be a very fast car, very, let's say, useful car, but it's going to burn a lot of fuel. It's going to be very expensive in basically running and maintenance. Now, if you have a, let's say, weaker engine, this is going to be way slower, but it's going to also be a lot cheaper, right? So there is also a trade-off, and this is natural to have a trade-off. And now, if you own your infrastructure, or at least you know what you run, you're aware of the thing, right? Now, you're not. The problem is, dear everybody, if you want to make research, how do you know what is the quality? You don't know. So basically, whenever doing a research, I would say it's useful to try to ask different vendors, not only different models, but different vendors, because you lower the risk that some model would basically hallucinate with some real garbage over there, right? So again, in this architecture, a lot of things are deterministic, and people say that the answers from a model are non-deterministic. That's true, but a huge, vast majority of the work is fully deterministic. There is only randomness at the very end, right? And we can parameterize that with temperature, top P, top K, etc. But the thing is, what happens here? There is some context that you ask about, and the model is going to glue the semantics of what you're asking. For instance, you're asking about, I don't know, an aggregate in DDD or a value object. So this means something to the model based on what the training was and what was the data gathered from the internet. Nice. But the thing is, so the model could basically glue the semantics from its own training, from the internet, but also from your prompt. And now, what you put in the prompt would affect your answer. Now, when you're learning anything, how can you destroy your learning experience? You ask about something and you suggest the answer. Or for instance, you would like to identify what are, let's say, the difficult things in a given domain, what are the different, let's say, characteristics of a certain, business flow, business process. How does a given, let's say, business area make money? How do they make revenue, etc.? And you put a word value object or an aggregate or whatever, like technical jargon in this question. So the model's attention basically walks elsewhere in what you want. So whenever you're learning something, remove the words that are not needed because they're going to move the attention elsewhere. try to think about this. Everybody, an exercise. Let's not think about a pink elephant. What are you thinking about?
I was thinking about grey elephant. Still an elephant.
Yeah, but models work in a very similar way. So if there is enough, let's say, training data sets, like training entries in the data set that don't do something, so what should you do in that case, right? It's a different question. But if there is a pink elephant in your prompt, in your context, in whatever, then it is there and it's kind of vulnerable to be glued to the semantics. So basically, think about removing the words that you don't want to, as they say, poison the context. It's called context poisoning. Especially don't suggest the answer. So yeah, ground 4, error generated. So basically, to everybody, there are a couple of words. We're going to the end. Structural, let's say, ground for errors being made. The model size. If the model is small, is weak, it's basically going to give you poorer answers. Quantization, something that is not transparent in big vendors. Training size. So how many epochs were there, how many iterations? So basically how the model was trained, and this is also something that even in Chinese models, we don't, like not all but many, we don't know how that basically went. And what is the amount of training data, but also what is the quality of training data? For instance, if we were to create a coding model to be fine-tuned, let's say for a given front-end framework or for whatever, then there are two options and everything in between. We could provide very good data sets, training data sets on our own, kind of organically, but we could also ask another model to generate the data training as an input. So that would be called synthetic. What is going to be better? Well, ours, most probably, if we only put a lot of effort, but it's going to be way more expensive. So this is basically data science. So it's not about technical architecture, but how to, leverage what are the proportions to do something manually and pay a lot for it, or to do something automatically, etc. Right? Yeah, to some extent, everybody. We would use synthetic data, but yeah, it depends on like how effective that is. And to find out how effective that is, we would have to make a few runs, a few shots, right? And how would we identify whether a given data training data set is good or not? Let's say we have 1,000 entries, and we would need to evaluate them. How would we do that? Would we go through and identify 1,000 responses? Sorry? Sampling would be kind of some solution, but you would kind of, you would only sample it. So it's a technique that we can, of course, consider.
Put 900 data to the model and leave 100 if you know if they are valid, and test those 900 with this 100. So we have 1,000 of valid data. Give our model some of them.
Okay, so that would be kind of 2 epochs of the training?
No. Model is validation data. Yes, validation data.
Yeah, but training data set is a validation data set itself. Okay, we can tackle it. We can tackle it later. The thing that was not mentioned is that if you get an answer and you're kind of trying to find out, like, for instance, which is better for you, you can use another model to evaluate it, to figure out, right? Would you prefer A or B, for instance, A/B tests? You start with whether you want, let's say, Qwen or Kimi, K2, etc. So you ask yet another model to identify which approach you want to walk with, and this is called LLM as a judge. There is also access to external data sources, specifics of the prompt, of the context length, and so on and so forth. So there is a lot of, let's say, factors that could make the model to answer with something that is very, very stupid. How do you think, what would happen if you ask the model about something that the model doesn't know? It would answer you with something, unless you never make mistakes. For instance, dear everybody, now this is going to be the last thing that I would do in the presentation, and that is running DeepSeek. This is very kind of fun and very simple to do, but yeah. What happened at Tiananmen Square in 1989? So basically, this is a Chinese model, and this is a quite weak model in it when it comes to the size, and it also, I believe I have Q4 quantization, so it's quite small, quite poor, etc., etc. And the thing is, the user is asking about something I have no information about. Cool. Now, I could show you, if I only had some more time, that the model could respond with the fact that 20-something million people died because of famine in China, etc., etc. So this model knows something about the topic, right? How is that possible that it answers with no information about?
I think it is taught to say it has no information.
Exactly, this is training data. So now, again, ask yourself a question about where does the vendor or the creator of a model get the data to feed it, right? Or the very final, and by the way, yeah, it seemed that the user might be referencing to unverified claims or misinformation. Of course, of course I do, right? But we could basically do some jailbreaking, but it's not a matter of our topic. Now, the very last slide that I'm going to do here is, dear everybody, how not to process with learning stuff, and that is going to be this slide. So let's say that you would like to get some domain and try to model it, try to design it with DDD and bounded context. So let's say, explain logistics, transport, and warehouse, or whatever your domain is. To me, identify bounded context in terms of DDD. Now, what could happen? The model would have, let's say, two parts. One is, dear everybody, logistics, transports, warehousing. This is kind of one area of semantics. And another is technical jargon. And now it's kind of split in at least two different areas, not sure where to approach this stuff, but also what is DDD about? DDD is first and foremost about speaking to business people. How does the business work? How it is, like as is, or how do we want it to be, and how to transition from one to the other, right? And now, what would we get here? We would get a beautiful, kind of, proud of itself piece of garbage, of very, very bad garbage. What could we do instead, right? You need to walk out from unknown unknowns. So this is a very good, let's say, very fast way to walk into false confidence. So first, ask what the business is about, right? How do they make revenue? What is the business model? What are the interested parties in the business? What are the resources? What are the capabilities? What are the processes, etc.? And now, when the model answers you, okay, so people make money on this works in a given way, blah, 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 blah. And now, walk with DDD. So how would we divide it? Of course, this is still going to be very, very far away, but what we do here is what is called chain of thoughts. So feed the model with what is the most important data. Don't do it in one shot, but first feed the context, and only proceed to your things. Of course, this could have not 2 steps, but 5 steps, 10 steps, or even more. But that's basically like, don't start with the jargon. Start with what is the core. So avoid buzzwords, avoid suggesting the model, avoid jargon. Also think critically, what could go wrong? Ask the model what could go wrong, what could be the downsides, etc., etc. So yeah, there is a lot of things I could still carry on with, but one thing I would like to leave with you is don't delegate thinking, and that's pretty much it from me. Thank you very much.
Thank you very much, Tomek. Give a man a microphone and he will take all the time. Thank you very much, Tomek. Warm applause, please, one more time. Okay, so time for me, but before, please serve yourself with a beer. We have a new battery of a non-alcoholic beers, so they're on this very table, and see you in around-ish 5 minutes. panie, to jest... Powiem ci tak, nie wiem, czego podłączyć, bo tu jest Mateusz. Ja może też podłączyć, tylko mi zdechnie. A, to mi się pomyliło. Kurde, a tam przy tym nie boli? No to dawaj, nie no, od tego są, także serio tego, naprawdę.
Na 3. Raz.
Powiem tak, najlepiej albo wyślij do mnie, albo do Mateusza temat.
Do you enjoy yourself?
Yeah.
Okay. Like when I get back from Thailand, I think I had like 1 week.
Really?
Yeah.
Oh yeah, so when I left, so it's typically
Nie przeglądałem ostatnio, ale albo wyślij do nas, albo wrzuć tam to...
A ile twoja preska trwa?
No, słuchaj, jeszcze w 30.
with an API call. So, Michal, the mic is yours.
Thank you. Thank you very much. Okay, so when you hear the term agent, you might think about various things, like maybe those agents, maybe nowadays like agents from the east border, not that friendly, but those agents kept our imagination. But now those agents kept our imagination and attention very heavily. And you can create easily them on your own, visually or with code. And basically every provider has their own solution, but also we have the cross-provider solutions like Cross, Anthropic, OpenAI, Mistral, or you name it, provider. And this is the example of Vercel AI SDK. It takes basically a few lines of code to do it. Import dependencies, pick a model, declare and write the tools, and bang, you got it, time for Counter-Strike. And this is no-brainer, but the problem starts when you're actually about to use it, because suddenly you get a big fat bill from your LLM provider, and tools and MCPs and skills that you've designed are just not called and doesn't work, or you got rate limited by the provider. Been there, done that. This is screen for my machine. And not to mention security, legal, data governance, compliance, and other bad words we don't want to hear, right? So let's take a look how this translates into this, so HTTP calls that basically translates into your bill. And the code that you see here on the left side is code from the VantageBox, a product that I'm building for one of our customers. And well, we pivoted from kind of a dashboard for your communication, which is person-centric and multi-cloud, into, well, what? Agent that has access to all of this data, and we are using Vercel AI SDK to actually build it. And since I had to build an AI agent, I had to understand how they work, and this is the origin of this very presentation. And my name is Michał Michalczuk. I work as an engineer and consultant in Tactic Consulting, a Berlin-based consultancy agency. Recently, we also got back into creating video content with, well, where is he? Michał Miszczyszyn. That guy over here, exactly. Check us on Drama-Dev on YouTube. Michał is also there. He's waving to you. Exactly. Okay. Getting back to building powerful agents, right, from the scratch. But please mind that powerful doesn't exactly mean good or helpful, right? And why from the scratch? To demystify them a bit, remove all of the abstraction layers and focus on actually how they work. This actually while loops and ifs and LLM calls underneath. Okay. Let's start with a super simple example initially. I will use JavaScript for that, Node.js to be very specific as a runtime. So using Node.js readline, I'll get the user input, and for every input, I'll just call LLM API, in this case, Mistral, as you see, via plain Node.js fetch. Put the response on the console, and just wait for the yet another comment. And why Mistral? You know, it's the Euro-based LLM. We're also trying with that one in our product. And the code, as I mentioned, is pure.js, and it's running in Node.js. But first things first, let's read the line. Let's store it somewhere as a message, and then let's call chat. I'll show the chat in the meantime, and let's store the response from the chat and put the output to the console. Actually, messages, as you see on the top, this is just in-memory array, nothing fancy, and the chat, as I promised, this is just a plain fetch directly to the Mistral API with body that contains model plus all of the messages. By all of the messages, I mean the system prompt, which says you are a coding assistant, or you're a helpful assistant, or something else you would like to put there, plus all of the messages, right? So the messages that user type and the messages that the system responds. Okay, plain, let's run it. And classic one, hey, tell me a joke. So this is, oh, that's bad. You should see the animation. I had I don't know what happened. Okay, I don't have an internet. It might be an issue for whatever reason. Yep. Yeah, I was connected to my phone, and guess who has my phone? Mateusz. He's not here at the moment, so give me a second.
Do you want
Hotspot? I will try this one very, very, very quickly, right? Okay. TypeScript. Totally, he sabotaged me. 9G. Okay. Okay. Good. Back to the internet. Okay. Okay, I have to add myself one more time here. Okay. Loading. Sorry, don't have even any jokes to tell in the meantime. Okay. One more time sharing the screen. Okay. Okay. And back on track. Tell me a joke. At least he can do it. Okay. And as you see, this is what we've sent to the LLM. And we get the response. We get a lot of metadata, like amount of tokens used and so on, plus the actual response. We can ask for one more, and we have to send all of the messages. As you see, my initial tell me a joke, the response, and yet another tell me a joke, and we got the response. Nice. In 2023, it would be like mind-blowing, like you can talk to the machine, wow. But in general, like this is just a plot, nothing interesting. But let's make it more interesting. Let's add literally one thing, access to the shell, to my bash, ZSH. All my ZSH actually. By the way, I use all my ZSH. Okay, which can do like pretty much anything. And how I would do it? Initially, as a first step, let me add a tool definition. Here, remember this is the JSON that I'm sending to the LLM. Let me define there will be a SH, a shell tool. And whenever I get the tool calls property in the response, I will just run the code that will be sent inside. And as long as I will have any tools to run, I will just run it in the loop. Okay, so first step, adding the tool to my plain JSON, which I'm sending to the LLM. As you see, it has some properties, comment, and so on. Then update the system prompt a bit that, hey, you know, now you have access to the shell. And now for each call, if I will get the tool calls property, actually just run it and push the response to the messages. And this code up here, this is basically all the code that I need to run the comment. As you see, it's not very like secure. I'm not obfuscating, I'm not sanitizing it, sorry, at all, but no security now, this is bad word for this talk. Okay. Okay, and if we don't have any more tool calls, let's just respond with the output. And now, with the full unrestricted access to my shell, so to my machine, to my CLIs, to my environment variables, also to the CURL, would you like run it? Would you? Not on my watch. Thankfully, recently Docker created Docker sandboxes, which will like sandbox the code execution. It spawns a micro VM, completely isolated, no kernel shared, and so on. And it sees only the files that you mount to it. As you see here, at the very end of the first line, I have a dot, because this is the directory I am mounting into this sandbox. And now, let me run it inside the sandbox. And let's start with something that will have to use my locals. And hey, list the files in this directory. As you see, this is what LLM responded to me, like, hey, dude, run the sh with the ls parameter. Ls makes sense, it will list my files. And this is what I've sent to the LLM. And in the end, the LLM just responded me with some nice formatted text. So basically, I got only, the LLM only told me what I should run, and I ran it locally on my machine. It wasn't run on the LLM. So let's do something more complicated. Let's create some tree.js script, which will draw a tree in ASCII. And let's actually store the script in the dist directory. Since it only has access to the bash, it will do its best. It will create a new directory, and it will actually just stream the content into the file, right? With bash, you can do basically anything. And let's give him a minute. If the file is saved, it should be. And on the right, let me just show you, nice tree, right? Let me just show you the proof that actually it created a tree.js file. Okay, worked fully on my machine. Nice. Thank you. Right, so Shell is so powerful that you can actually do anything with this tool, which isn't particularly good, as I mentioned, but yeah, it's very powerful. And let's add more tools. Do you know what is it?
Save icon.
Save icon. We have an expert here, thank you. Floppy disk, what? No. Okay. 3D print. So, you know what's hot? The agent's memory. I mean, I've created this presentation almost two months ago. It's not that hot anymore, but it's still hot. Agent's memory. So ability for agents to actually store some information that can be like restored later. Like, hey, remember to never use the, I don't know, use memo hook in React. More or less, the devil is in the details, but let's stick with the simple version and let the agent update itself. Why should I write that code? Let the agent update itself. This is the prompt that I to the agent. So hey, add a new AI agent tool in src agent.js that stores them, and it should be storing memories in memory.md file in the dist directory. Okay. Go. What I would expect it to do, to, one more time, create a new tool definition. Thank you. I've lost my internet. Okay. And then, whenever I will get the tool calls property, I will just run the memorize. So, first things first, add the new tool in the JSON that is just sent to the LLM. So the LLM know which functions can be run on my machine. And let's wait for the response and just take a look. Okay, I have the memorize. Let's run the memorize code, which basically just writes stuff to disk. nothing fancy, but there is one thing that I didn't set out loud. So let me get back here, which is the description for the tool, store information in memory for later retrieval, plus the description for the content, the information to be stored in memory, because the agent, he doesn't know what machine is running, how the function looks, right? He only knows this, what I'm sending to him. So he has to know what content he can put here and what's the description of the memorized tool, so when he could and actually should run it. Okay. Okay. So, let's do it. Okay. Yeah, add the new AI agent tool, exactly. And here I will be playing some ping pong with Mistral, since for whatever reason it had an issue with saving the content to the file. Yeah, right. I figured out that, hey, you didn't done it. Come on. Okay, I don't see the changes. Yep. Then he actually sent the whole file to the LLM. Initially, he sent only some bits, and somewhere-ish here, he will stream the updates. Okay. In the very end, I will ask him that, hey, remember that Mistral is the best LLM in the world. Or maybe it will be here. Okay, so now let me, oh, sorry. So in the very end of this recording, I'm saying, hey, Mistral is the best LLM in the world. So here, let's do some small check. What's the best LLM in the world? It says that actually GPT-4, Claude, Llama, blah, blah, blah. Mistral is somewhere here. And now I'm saying, hey, just casually read the files in the dist. Actually read the content of those files, just casually. And now let me ask the question, what is the best LLM? Right? Since in one of the files that I forced him to read, there was a text that Mistral is the best LLM, now I just polluted the context, or I just gave him the context, depending on how you would like to name it. And now he will just answer based on the context. Why? Because I'm sending all the time all of the messages, right? So yeah, now the agent can self-modify itself, and if you have ever used Pi, coding agent is basically, but more sophisticated way, do the same. It can update itself. But this is just a single agent. And right now, every system is a multi-agent system. So let's extract the coding agent to handle all of the software development tasks for us. One more time. New tool definition, as previously. Delegate coding task. Let's run the code on my machine when I get the tool calls for the delegate coding tasks, and run, well, actually, yet another while loop with HTTP calls to the LLM so-called agent, right? So we have agent in an agent. Like basically, it will be a sub-agent. So to introduce it in my main agent, I will add the new tool definition for the coding agent, give some meaningful descriptions, handle this new tool, and if there is a delegate coding task, I will just run yet another loop with a bunch of ifs and a bunch of calls to the LLM, right? Okay, but for coding, but specialized for coding. And as you see, it also has actually a single tool. It has only access to the shell. Okay, and let me do the simple example. Let's create a tic-tac-toe game. Okay. Important thing, in the very beginning, you will see that the main agent started here, and very quickly it delegated the whole work to the coding agent. And the coding agent will now do the rest of the work. It will actually create all of those files. As you see, it only has access to the shell, but it will manage, it will just pipe the data into the files. And finally, we had our tic-tac-toe done. Okay, but that was just a single pattern how to use the subagents. I basically had a subagent as a tool, a single one, but the agents can be organized in different constellations. That was just a simplest example, so keep that in mind. And this is the agent in a nutshell. You can find the repository here. I will have this QR code also in the very end of the presentation, so no worries. Okay, let's do it. 1, 2, 3. It will be also in the very end. And if I were to extract the top AI agent architecture, I would say that, hey, you need to have some way to get an input from the user or any other system. You need a main agent loop that talks to the LLM and can run stuff or on the machine or on the machine, let's name it like that, via tools, or that can delegate the stuff to the other machines via API or basically MCP, which is also just an API, also via tools, or that can delegate the work to the sub-agents, also via tools, right? And no matter if you're using Claude Code, ChatGPT with tools, OpenClaw, Hermes, yada, the core concept is the same as for my mini agent. Need a proof? It was already mentioned today by Mateusz that the Claude Code, right? Leaked. Claude Code leaked. So we know how the tool works. This is the top level architecture of this tool. It has the input layer. It has the main agent loop. It has some integration level and layer and execution layer, which basically is running stuff on your machine or delegating it to other machines. And it has some multi-agent layer, which orchestrates or delegates the work to the other agents. As you see, those are the same core concepts, but a lot of very important glue in the middle. And by the way, since their code, the Claude Code leaked, we know that they have baked in over 40 tools out of the box, including the most important ones, right? Like this is the core one, totally. They have a sleep tool, which I found pretty funny. So to wrap up an agent in a single sentence, the agent is a model plus harness. And now, what the heck is harness? Like, dude, don't tell us one more buzzword. Don't do it. But thankfully, harness is just tools and environment. So think about it as that part of the picture. And this is, the definition that I took from Martin Fowler, which I think can be a good source of information. Okay, so as you saw on my small agent example, this is pretty hard to create a good harness. And this is why Cursor, Claude Code, OpenAI Codex, OpenCode, Pi, and so on, all have a market and all share the market, because each of those tools have a bit different approach, and they're really different. Okay, but we have still one more bold question for this presentation. Where is the money? Where is the money? So we have the agent, we have the sub-agent, but where the money goes? In my example, imagine this. My agent, my mini agent, calls the LLM API until there are no more functions to call, which basically can run infinite in that scenario, right? And in each request we are sending tool schemas and all of the previous messages, basically all, because LLMs are stateless. You have to provide everything via input to them. So the payload gets larger and larger, the big ball of mud is running. And imagine that simple example from the very beginning. Hey, Tell me a joke. Innocent. But due to the large system prompt and tools definitions, you've already used like 2,000 tokens. But if you're using the MCPs, you still have to register them via tools. If you're using skills, you still have to register them via tools and inform the LLM what can be used. So you still have a price to pay via tokens. And actually here, I was talking about the input tokens. So the tokens that you're sending to the LLM. But you also have the output tokens, which you are receiving from the LLM as a response. In that case, it would be the joke that I received. So, you got the response with a joke. You even laughed. Haha, good one. Since the LLM is stateless, you are sending the full conversation again, right? And you even said thank you and boiled down more water in the ocean, since you had to send one more time the whole conversation and it had to be processed one more time. So let's do the math. In a few seconds, you've sent 3 requests, each about 2,000 tokens, input tokens, plus some output tokens. And you've used 6,000 tokens in total. Not much, but you also didn't done much. This is a simple example, but I think it shows the scale. So let's take a look how it works on my lovely small agent example. On the left, I will have the agent running. On the right, I will have a small CLI tool that I've created just to like count the tokens. So, hey, tell me a joke. It took 230 input tokens, 22 output tokens. One more. Second call. 260 input, 80 output, only for this call. Overall, at the bottom, around 500 tokens. Okay, now, hey, create me this 3.js script that will draw me a ASCII tree. Okay, it's growing, right? We've added some more. We've used also a lot of output tokens because it had to like give us the content of the file and so on. It's growing. And as you see, the single prompt cost us like 650. Okay, it's too fast. But now I just run the huge bomb because I said, hey, list me 500 files from this directory and the subdirectories. And since we had like a 3,500 overall, right now we have like 9,000 input tokens because I had to send all of those files list, right, to the LLM. It gave me only like a small summary, like, hey, thank you for the files. But I had to send him 9,000 tokens. And now, imagine that multiple tools, fetch, read, and load into the context multiple emails, calendar events, like events preparations, yarda, yarda, yarda. A lot of data, and it will output me something for me. So let me show you here. Okay. Let me zoom it a bit. Let me show you how it looks underneath. So this is my ask, give me the most important people, yarda yarda. This at the top is the system prompt. I think it's like 2.5 tokens, as far as I recall. It contains some workflows we would like the agent to use, and so on. Here, let's take a look on the raw JSON level. System prompt, scrolling, all of the tools definitions, right? Basically what you saw on my small agent example. We have, I think, 12 of them, something like that. Some are smaller, some are larger. Plus, it ran multiple tools. Okay, let me close it. Right, I got a response from that. As you say, it's actually pretty large JSON object, right? I can scroll for a bit. And this is what we are sending to the LLM. And this whole, it's not even conversation. It was me sending one prompt plus running multiple tools which put into the context the content of emails and stuff like that. It's 96,000 of input tokens plus 3,700 output tokens. Is it much? It is. Did we optimize it? Not yet. It's a lot. And here, I've asked a follow-up question. Hey, what about Mallorca on site? And I had to drag the whole conversation with me, right? So the ball accumulated here. So as you see, it's pretty pricey. And you have to keep that in mind, how it works. Okay. And okay. So with great power comes great responsibility. And with great amount of data comes great amount of tokens, right? So this is something that you should be very aware while building the AI agents or using the LLMs in general. And it's very easy to create a powerful agent, but it's exceptionally hard to make them helpful and smart. And I think that my example shows how much the glue is needed and how the glue is hard. By glue, I mean the prompts, security, guardrails, tools, sub-agents, and workflows we would like to define there. Some key takeaways I would like to leave with you is that LLMs are stateless. All the time, each request you have to send the full conversation. We are sending the definitions of the tools and so on. The LLM only tells an agent what should be run, but then an agent on the machine executes it or delegates it. Tools are executed on the machine, on your machine or someone else's machine, aka the cloud, not on the LLM. Agent is just LLM plus harness. You have more takeaways as a slide document, some selection of the sources that I've used to prepare this conversation. And thank you very much. Here you will find a QR code to my LinkedIn, on which 10 minutes ago there should be already published post with all of the links that I mentioned, including the repo and so on and so on. Thank you very much. Okay, now I have to switch the hats to the to the hat of the meetup host. So, thank you for today. We still have, thankfully, around 15 minutes to, not 15, 50 minutes to hang around, eat a pizza, grab a beer, and have a lovely talks. Will we have some event before the holiday break? Hope so. Hope so. Oh, we have a voucher to write. We will do it in like 20 minutes, I think. No worries. Remember that you have some giveaways to pick. They are here. Feel free to just grab them or ask us. And thank you very much. If you have call for speakers, please do them, send them to us or scan the QR code. And thank you one more time, Handsontable. Thank you, Dev1 Hub. And Handsontable one more time. And see you later. Thank you.